Good morning, Nandika. Can you hear me? Good afternoon, Nandika. Can you hear me? Okay. Uh, Surya Teja, can you see the screen? Okay. Yeah. Good afternoon. Let's start today's session. The second half of the Unit 2. The first half was basically depending on the dictionary, and the second half is going to be hash table basically. But at the end of the Unit 2, you will realize that hash table is another form of dictionary. Hash table is another form of dictionary. So, like how we had a key and value, key and value in the dictionary, and in the script list we made use of that. On the similar basis, in the hash table also we continue to use this concept of dictionary, that is key and value, and in a different data structure format, different data structure format, we are going to make use of this key value concept. As per your syllabus, your hash table representation, which is the main heading of this particular part of the Unit 2, we have hash functions, we have collision resolution. In the collision, if the collision happens, then separate chaining, open addressing, linear probing, quadratic probing, double hashing, rehashing, and extendable hashing. These are all the parts of your second half of your Unit 2. Second half of your Unit 2. So let's focus on the Unit 2. Let's focus on the coding part also. As I told you that my aim is that at the end of Unit 2, your logical thinking should go so high that it should be somewhere around, out of 10, it should be 7 or 8 minimum. If it is 7 or 8 minimum, then you will be absolutely comfortable, and I'm telling you that those who can understand, repeat the code, execute the code without, and after making a little bit of corrections, see that the code is executed, I'm 100% sure that you will be qualified in one of the good companies. So going forward, let's start with the hash table representation. A hash table is a data structure, right? Everything we are talking about are data structure, right from what is the built-in data type int x. X is also a type of a data structure. So starting from that, we progress to arrays, then we progress to structures, then we progress to linked list, then we have progressed to skip list, and now hash table, right? So all are gradually the senior level or the higher level of data structure concept. What I can say. Students, those who have joined a little late, I hope you are able to hear me. Hello, students who have joined late, are you able to hear me? Is my voice clear? Guys, are you able to hear me? Those who have joined little late, not Nandika and other fellows who have joined in time. Okay, looks like there are no issues. Okay, so hash table, what we are going to study is again one more form of data structure, hash and table, right? Nowadays, you open Arnab channel, Arnab Goswami. I'm sure all of you know that news anchor who shouts more than giving more news, and who doesn't allow, he calls everybody for debate, and other than him, nobody speaks. So that fellow, every day there is some hashtag Ria, hashtag Sushant, hashtag something and this and that, nothing connected with the nation, what is happening in the nation, but all bloody humbug. Sushant Singh Rajput has got nothing to do with our country and our subject and the topic and the COVID. And that Sushant Singh Rajput, hundreds and thousands of people get killed, murdered. And this guy has last almost one month or so, he is in news. Anyway, forget about that. So that you must have hashtag Sushant, hashtag Ria, hashtag this, that. So that is that hash. Okay. So hash table is a data structure which stores data in an associative manner. Now, this associative means what? Associative means corresponding to key, the value is associative, right? Corresponding to an index, the value is connected, right? So, in a tabular form, corresponding to an index of an array, the value is associated with it. Corresponding to an index of an array, the value is associated with it. So that is what is your in an associative manner. So we draw a table in which there are indexes, and connected with that index there are values. So hash table is a data structure that is used to store key value pair, right? What you have seen in dictionary. Yes, it is continuing in the same form, but it is not what we studied in the skip list. Skip list was one way of looking at it. We added express nodes, express linked list, and we helped ourselves in doing the fast searching. Here also, this is a mechanism of doing fast searching. And that's what we are going to study in a different kind of a data structure. So in short, it is an alternate way of storing a dictionary, right? Like your skip list, it was also storing the keys to values. So also in a hash table, we are going to store, we may not call it as key directly as you see in the table, but through the key, we produce an index, and through that index, corresponding to that index, we'll link it up to a value. It's slightly different. As I progress in the class, you will be able to appreciate the difference between the skip list and the hash table. So the hash table is a data structure which stores data in an associative manner. So what is this associative manner? I would like to demonstrate with this small graphic. A hash table is a data structure that is using key value pair, right? Now, there's a key which goes in as a parameter. This key, make an assumption that the key value is 12. It goes in as a parameter. Yes, students, anybody? I saw some movement in the chat window. Is there anything? I hope you guys are able to see the screen, able to hear, because if the basics are understood, the coding can be done. If the problem is understood well, the coding can be done. So I'm going to spend some time in explaining you the algorithm so that you can always map what is this algorithm connected with your code. Okay. So you are passing key as a parameter to a hash function, which is depicted by this black box. So this hash function's h, assume that Division is one of the most popular hash functions. Division is one of the popular hash functions. What is hash function doing? It's taking the key value. It's taking the key value as an input, percentiling it with 10. Means some number 10, not, and you may get it out that who is going to decide that some number. I'll come to that. It is not that at random I have picked up 10, that some number which presently has been taken as 10. So this key, say 12, is percentile with 10. That will result into the I value. What is 12 percentile 10? 12 percentile 10, obviously 12, good. So that 12 and I is generally, yeah, thank you students. It gives me a good high when I see that scrolling in the chat window. So I come to know that yes, you guys are listening to me, you guys are responding to me. I'm also conducting a class in the evening. I'm taking Java for non-KMIT students. Once I tell at least 20 students will come in the chat window and respond like our good KMIT students. And it's exactly opposite. The non-KMIT students, I'm taking a class in Java. 20 times I request, Arey, come to the chat window. I shout at my top of my voice call them by their name. Hello? Hello? Is the voice breaking? Hello? 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 Okay. Some student said it's breaking. Or maybe it's a local issue with one or two students. Please check your mic. So I was telling 20 times I tell them, 20 times I pick up their name and tell them, yeah, come in the chat window. And after 20th time, they come to the chat window. It's so boring to teach them, but can't help it. Anyway, so 20%, 12 percentile 10, I. And I, popularly, we use that as index of an array. Right? Now, it's not a convention, but in most of the code, you will say index of an array is represented by I. Therefore, I have also picked up that I. Right? So, this index of an array is written as 2. So, the key which is given to the hash function, the key which is passed as a parameter to the hash function, it returns back, the hash function returns back the index of the array. Hash function returns back the index of an array. So, this is the concept. So, that is how, and corresponding to that particular index value 2, we are going to store the values. At the index value 2, we are going to make use of this index value 2 to store values. We are going to make use of this index value 2 to store the values. Maybe at that particular index, or maybe using that particular index somewhere, some other mechanism we'll see in today's class. That so first thing is to get the index value, right? So that is what is our hash function. So hash table, in hash table, data is stored in an array format. Data means what? Corresponding to a key, I have produced a index of an array, and that at array I'm going to store values. And at that array I'm going to store values. So repeat again, in hash table, data is stored in an array format where each data value has its own unique index value. Each data value has its own unique index value. Access of data becomes very fast if we know the index of the desired data, right? I do not know. There may be a lot of questions in your head that how come, and I mean, when I started your data structure, I said that array is something which is a static pointer, right? So at the beginning of the code, you have to declare the size of an array, which is not desirable because we are moving in a dynamic format. If required, we'll allocate the memory, and if required, we'll store the values, right? That's the concept. I'm not going back and front or not. I'm not countering what what I had already said. That the array structure which we are going to use in today's class, as I progress in the class, maybe after half an hour, you will be able to appreciate what I'm trying to say. That here, that array size, which is a limited size. We are not going to create an array of 1 lakh or 20 lakhs or 1 million or something size. We are going to use an array of a small size, which is manageable. And every key we are going to hash it into one of these manageable indexes. Every key we are going to hash it into one of the manageable indexes. So once these indexes are well within manageable limit, the searching operation we are going to make it faster. The searching operation we are going to make it faster. Let us see. I hope you will appreciate once we progress in the class. I'll pause and maybe I'll ask you guys, are you getting what I'm trying to say? Thus, it becomes a data structure in which what hash table becomes a data structure in which insertion and searching operation are very, very fast. Insertion into this kind of a hash table and searching from the hash table are very, very fast. Now, because insertion and searching are fast, so obviously you must have guessed that even deletion can be done faster. For deletion, what is the criteria? For deletion, what is the criteria? If I want to delete a particular data, if I want to delete a particular data, first I will look into the table. If it is there, I will delete. If it is not there, I'll say data not found. If it is not there, I'll say data not found. Therefore, I will just focus on insertion and searching. And in the insertion also, students, I hope you guys are keeping your ears sharp. I said that the basically, though I'm talking about hash table, but it is a form of a dictionary. Now it's a form of dictionary, means what? Key has to be unique. Key has to be unique, right? And when I'm doing insertion, I'm not violating from the basic principle that because it is a hash table, I may have two keys. I may have duplicate keys. No, we are continuing to stick to that particular concept, but we are trying to understand a different kind of data structure. So hash table uses an array as a storage medium. Hash table uses an array as a storage medium, though not very, very appropriate, but let me give you one small example. Any standard textbook has got a content page or an index page, what they call. Content page, I think index is at the back, content page will be more appropriate. So the content page, in the content page, you have the topic name and you have something like Unit 1, page 1 to 13, Unit 2, page 14 to 28, isn't it? So if I want to go to Unit 2, I don't have to keep on turning the pages one by one till the time I reach Unit 2. I go there, see in the content, I have to go to 14 page, I straight away turn to the page number 14 and start reading Unit 2 onwards. So also the index, which is generally at the back of your page. Some keywords. For example, dictionary, right? If you are trying to read some kind of a data structure book, you go to the index and in the generally it is in the lexical manner it is stored. So in the D you say dictionary, and in front of the dictionary in the bracket it may be written 6, 13, 112 like that. So this dictionary word is defined at page number 6, page number 13, page number 112, right? Some information regarding that is there, right? So connecting that index, you go to that particular page and see the value, see the definition of dictionary like that, right? So hash table is going to use an array as a storage medium, right? Index is going to make our life easy to go to a particular value which we are searching, right? That's how this particular array is we are making it as an intermediate medium to look into the array for a corresponding value for a key. Look into the array for a corresponding value corresponding to a key, right? So the key has been sent to a hash function. The hash function has produced an index of an array, and using this index of an array, I'm going to reach to the value. Right? So hash table uses an array as a storage medium and uses hash technique to generate an index where an element to be inserted or is to be located from, right? So we are basically going to use this. For example, the key is passed on to the hash function. Just now you have seen that the division factor was 12. The key was 12. Division factor was percentile division was 12, and we came to 2. At 2, I have the value. The index is the index of an array, and at this particular index of an array, I have this value. So in this form, we are going to build this hash table. So this is my hash table. Which has got the index of an array, and corresponding to that index, I have the value. So what I have sent here, I sent 12, and corresponding to 12, there could be some value here, right? Corresponding to 12, there's a value here. Otherwise, what option I had? Here I had a linked list 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, right? So for searching 12 in the linked list manner, I have to go n number of times. Starting from link 1, 2, 3, 4 in sequential order, 12 times I have to move it forward. 12 times I have to run the loop, right? Unlike that, in the hash table format, I give the key to the hash table, come to the index and do it. So it is 1 to 1. It's 1 to 1. So that's how I'm making the search operation faster. Now, yesterday when I was talking about this, Aman Singh Jolly said, "Sir, what about the collision?" So let's first understand what's a collision. Now, the situation where a newly inserted key, right? Firstly, I want to insert a key. Yeah, so the key comes over here, given to the hash function. The division factor was 10, right? 12 was the key. The division factor was 10, and the index I got 2. Suppose I pass the key as 2. The percentile division continues to remain same, that is percentile 10. 2 percentile 10 is also 2. Are you getting my point? So a situation where a newly inserted value, that is 2, key 2, map to an already occupied slot in the hash table, right? In the hash table, index 2 was already occupied, as you have seen it here, right? 12 percentile 2 was mapping to 2, right? So in the collision, what I'm trying to say, that the situation where a newly inserted key, that is 2, mapped to an already occupied slot in the hash table, that is 2, is called collision, right? Is called collision, and must be handled using some collision handling technique. For example, whenever you are sitting in the class, right? It is an unconventional kind of a understanding between you students. Maybe when you go to a particular semester, you go and sit on one bench, and generally for throughout the semester, that particular bench is yours. That bench is yours, right? So it is almost kind of an index where on which you are sitting, right? Index at which you are sitting. Now, sometime it may so happen that today when you enter the class, somebody else is sitting, right? But he is your friend. So what do? He's your friend. You don't start fight. You don't catch him by the neck and throw him outside the class or do something like that. You find maybe probably next to him, if there is a space, you sit there. Or you look somewhere, empty bench or a bench which is unoccupied, and you go and sit there, right? So something like this we are going to implement in our collision resolution. What is the title? Collision resolution. Collision has occurred, so we will not say that sorry, 2 key can't be accommodated, you get lost, right? We cannot say, nor we are aiming at doing something like that. Either we are saying that, nor we are aiming at doing something like that. We have to accommodate, right? Firstly, have you understood what is collision? The key was sent to a hash function. The hash function has resulted into an index, right? And corresponding to that index, we have stored some value. Now another key has come, which unfortunately hashed to the same index. Unfortunately, hashed into the same index. So now this is a state where the collision has occurred. Collision is what? Dash, right? We have dashed into the index where there is already a value, right? So the situation where a newly inserted key mapped to an already occupied slot in the hash table is called as collision and must be handled using some collision handling technique. Those who are little attentive while I was showing you the syllabus, you must have guessed it from there that one of the probing techniques which are there, we are going to use that. What are the chances of collision of a large table? In a large table, what are the chances of collision? In a large table, will it not be there? Chances may be low, but you cannot say that there are no chances. Yes, as some of you are saying, chances are low. You are saying low or very low, but we should not reject a particular key just because it got repeated, even if I have taken a big array, right? The collision has to be resolved. The collision has to be resolved. Okay. So collision are very likely even if we have a big table to store the key. Likely possibility is there. That is most important. Low, very low, extremely low, but whatever you may grade it, low, very low, extremely low, that possibility is there. If the possibility is there, are you going to say, sorry, friend, this key I cannot accommodate? You can't. You can't. Right? That's who says Akshit. Akshit has very correctly said, but not zero. Right? I agree with you, Bharadwaj, that low, very low, extremely low, but not zero. So you have to handle it. Isn't it? You have to handle it. Therefore, the title, collision resolution. Collision resolution. So as you think, so collision has happened. So what's the alternative? Sir, do one thing, double the size of an array. Still collision, oh, make it 10 times the size of an array, right? But still if it continues, then you have to look for something else, isn't it? You have to look for something else. Okay. Now, in the earlier discussion, I said that who is going to decide this division factor, right? Or what is the criteria for deciding that what is my division factor? That percentile 10 was the last example, percentile 7 is in this example. Now, one kind of a easy kind of a technique. Now, in the previous case, if I have taken the size of an array as 10, my division factor becomes 10. Now, as you see over here, if this is an array, a table, there is an index and there is a value which I am going to store. A table corresponding, and I am going to take the value. How many are there? 0 to 6 means how many? 7. Right? Why 7? Why percentile 7? Correct. Size. Length of an array. Correct. So that they won't repeat. How? Why it will not repeat, Bhavana? Size of an array. Correct. Because length is 7. Fine. But why 7? Is there no possibility that it will repeat? As somebody is trying to guess. If greater than 7, it won't work. But it should not be like that, no? Prime number 7. Oh, good. You guys are thinking Yes, in a different angles, 7 differ remainders. 7 different remainders. Yes, yes, Nikhil Reddy. 7 different remainders. What do you mean by that? Can you build it on this? Why I have taken 7? Uh, Collision won't be there, sir. Collision will be there, no? Suppose possibility of collision is there. You can't rule out that possibility. So that index does not get out of range. Yeah, good. Collision will be there. Index won't go out of range. Yes, I agree with you. Surya Teja, good answer. Right? So, extending what the P. Surya Teja has said, that index won't go out of range. Right? Whatever may be the integer value of the key, it will boil down to between 1 and 0 and 6. It will boil down to one of the indexes. It will boil down to one of the indexes. Okay, let's see. Let's see. So, if my size of an array, the size of an array determines the division factor. There, in the example of 10, probably I have taken the size of an array as 10, 0 to 9, that is 10. In this particular case, I have the size of an array is 7. Therefore, the percentiling factor is 7. Right? Now, collision will be there. Now, let's make an assumption. My key is 50. My key is 50. 50 percentile 7 is how much? 7 sevens are 49. Remainder is 1. Right? So, my index, the first column is index, isn't it? The first column is index. So, at index 1, I kept 50. I have index 1, I kept the value 50. Right? So, this key is mapped to firstly using the hash function, which is percentile 7. I have come to an index, and at the value at this particular 50 corresponding to this 50, probably I have kept some value, maybe 50, maybe 60, whatever it is. Right? I have put 50 just to match that here some value is there corresponding to 50. Okay. Now let's take 700. 700 percentile 7, 0, isn't it? Agree? So I have got this, right? So far so good. Now 85. How much? 1, isn't it? 85 means 1. 7 ones are 7, 7 twos are 14, 14 plus 1 is 15, right? So 1. So now what has happened? Collision? Yes. So those students who are saying collision will not occur if we percentile it by 7. Now the collision has occurred. The collision has occurred. Do we say that get lost? No, we will not. Right? So one of the technique is what? I make a mechanism that I go to index here. I have stored a value corresponding to this 50. Yes, but I'll store a value corresponding to this 85. I put this in red because the collision has occurred, just as an indicator. How can we do this? Any one of you? How can I do this? Corresponding to this index, linked list is 1 answer, 2 answers, 3 answers. Okay, good. Pointers. Pointers, Rishita. What are you trying to say? Pointers, Rishita. Some different answer you are given. Maybe you have something in mind. Can you build on this? Be Rishita. Making another array with same size. Oh no. But now we are not talking about 7, 8 or 700. We are talking about millions of records. Separate chaining. Very good. Students, you are reading. You are giving very good responses. That makes the faculty take more interest in teaching, right? The students are opening the books, trying to refer what's going to come next, and giving some kind of appropriate answer. Very good, students. That's the way I would like it. But I was focusing on Rishita, that 50.285 pointer. One pointer you can store 50 as well as 85? Rishita, at by taking one pointer, can I store two values, 50 as well as 85? Uh, what array? I mean, you would like to put one array there? Continuous memory allocation locations. Okay. Okay, fine. So by continuous memory locations, probably we are again boiling down to linked list, which some of the students have answered. Right. But nonetheless, even in the linked list, there is a pointer concept. So more or less, you are right, Rishita. So one of the answers which the student separate chaining is one good answer which somebody has given. Abhinav, right? Linked list is another good answer which somebody has given. So, since you are aware of the linked list, how will you build this? So, what is the replacement of this? This should be this indexes should be what? If I want to go in this manner, array of structures, array of linked list. Okay, good. Durga Prasad, yes. Array of linked list. Yeah. So, array of structures, or some, I think those students who are trying to say array of linked list. I think you are meaning what maybe Aman Singh is saying. Open hashing, very good, Ajay. I'm happy to know all these keywords which you are using. Good. So now, if so, the collision. Now the collision has occurred, and you yourself, students, those who are keeping abreast with the subject or reading before the class, good. So when students like you come prepared, it encourages me. So collision has happened. So you yourself have come up with open hashing, separate chaining, linked list, right? All those things. And this particular array has to be a array of structure, array of structure pointers. So that pointers should be pointing to something. Okay. Now suppose we have got 92, right? So 92 again, 92. So there's an issue. Again, it has boiled down to 9 ones are 9, carry 2, 9 threes are 21, again 1. Okay, so this is how we should be planning. And using a linked list, going to this particular base address, go to the first node in the linked list, store the value corresponding to 50, right? If the collision occurs, then append to this linked list and store the value corresponding to 85. Again, you are given the hash key as 92. Unfortunately, again, the collision has occurred. So again, append to the last, right? And this is how you can keep on going, right? So whether it is 7, whether it is 50, 70, 700, 85, 92, any value, let any value come our way. We will be able to find the index by hashing it, and corresponding to index going horizontally, we'll be able to look into the value. So if we are interested in the value corresponding to 85, so what should be my data structure of this node in open hashing? What should be the data structure of my node? Won't there be a problem during retrieving? Why should there be a problem? Nikhil Reddy. what problem are you visualizing? But before that, some of you, while I'm focusing on what Nikhil is trying to ask, what is the structure of this particular node? Because you are suggesting linked list, open chaining, all those things, separate chaining. So what is the data structure of this node? Yeah, Nikhil. We go to index 1. Yes. Suppose I have to search 92. Suppose I have to search 92, right? So 92 has resulted into index 1. From index 1, I go one by one and look whether 92 is there. Now next time, suppose this value is 7, 8, right? If it is 8 percentile 7 is 1. Now I have come to this particular index, Nikhil Reddy. I searched here no, I searched here no, I searched here no. And then I say 8 not found. 8 not found. For large data, yes. For large data, yes. Therefore, for large data, definitely the search operation will be seen for large data. If you see the worst case, as Nikhil Reddy taking your point forward, worst case is what? Every key, suppose there are 1,000 keys, and unfortunately every key is hashing at 1. Every key is hashing at 1. That's the worst case, right? In that particular worst case, my search operation becomes n. N means what? If there are n nodes in my data, I have to run the loop n number of times. Right? That is the worst case which may occur. That's the worst case which may occur. But otherwise, when you come to other situations, it may not be that worst, Nikhil Reddy, right? So the worst case, as you are visualizing, that all the keys hash into index 1, in that the search time taken to search is equal to the number of elements which are there in the data. Okay, Nikhil Reddy? Okay. Nobody is answering me. What is the structure of this node? Node, linked list. So this has to be node. Now I have to store corresponding to 50 some value. Struct node, int value, struct node next. Anybody else? Can somebody improve what Durga Prakash is saying? Is it sufficient? Struct node pointer next. Right, int key, int value, and struct node pointer next. Right, that could be better way. Because first I have to come to the key. Corresponding to the key 50, there is a value. Right? So the data structure we can say design in such a manner which can store the key, the value, and pointer to the next node. Okay, so you understood collision. You understood how collision occurs. In case collision occurs, you have to find some kind of a mechanism. There is another mechanism, students, which is called linear probing. In the linear probing, what happens is, suppose I have given 85. Now 85 has, before that I have given 50. 50 has resulted into index 1. And at index 1, I have already stored the corresponding value. Now I have given 85. Right? Now 85 percentile 7, the remainder is 1. Now I come to 1, but it is already occupied. So since it is occupied, I increment it by 1. And come to index 2, and check whether index 2 is free. If it is free, I push this 85 here. That is another logic. The third alternate logic is that along with this division factor, you also give a seed. And what is the seed now? You also give a seed. Seed means what? That seed could be 2, 3, but definitely less than the size. The seed could be 2, 3, but less than the size. So suppose the seed is 2. Suppose the seed is 2. I have already given 50. It has index is 1. I have pushed value corresponding to 50. Now I have given 85. The seed is 2. Seed is 2 means what? It has come down to index 1, already occupied. So I jump 2 steps, right? So instead of pushing the value at 2, I push the value at after 2, that is 1 and 2. Now again I come to 92, right? 92 has come to index what? 1. Index 1, there is already 50. So I look at by adding the seed 2. So I come here, again I find already 85 is there. Again I increment it by 2 and come to 5 and push 92 here. Push 92 here. So there are certain linear probing techniques which have its own algorithms, which we'll see when it comes. Let's not try to learn everything in one go, right? Let's go step by step. When a hash function maps two different keys, at same table array index, a collision is said to occur. So that's how the collision is defined. That's how collision is defined. When a hash function maps two different keys to a same table address, collision is said to have occurred. Why is hashing needed, particularly when collision takes place? Right? Why means just now we have seen ample number of examples wherein we have witnessed that collision is occurring. Collision is occurring. Yes. So the obvious question comes to your mind that when we know that collision is going to occur, that is whether I take the division factor as 10 or I take the division factor as 7. All of you in the previous discussion, you said there is a low possibility if I increase, but there is a very, very low possibility, but one of you has said that it is not 0, right? So the fact is that when you're subjecting the key to a hash function, the possibility of collision is there. So why hashing needed, particularly when collision takes place, is the obvious question. Yes, when you know that corona is harmful and when you avoid social distancing, there is a possibility of you catching with corona, right? Why go and mingle with people without maintaining social distancing, right? Similarly like that, when we know that whether your division factor is 7, 10, 17, 20, whatever it is, collision is going to happen, then why hashing is needed, right? So the answer to that is hashing is used to index and retrieve items in a database, say array, because it is faster to find the item using the shorter hash key than to find it using the original values. Means what? As I said, that first we started this semester with linked list, searching operation, sorting operation, everything we have done, so many exercises we have done in linked list, right? But linked list, as you know, it is one of the linear data structures. Means you have to know where the linked list is starting. So starting from the first node, then only you have to do the search operation. Okay. So by using this hashing technique, your searching operation is going to be faster, right? How you use the skip list technique to come to the express lane and carry out the searching faster. So because the searching is faster, though the collision is occurring, we can still depend on this hashing table. We can still depend, or it is very, very dependable to use a hash table and store our values corresponding in a tabular form in a hash table, right? So definitely hashing is needed. definitely hashing is helpful. Collision may occur in hashing, but hashing is not a collision resolution technique, right? Hashing is not collision resolution technique. Students, are you understanding? Collision resolution techniques are, as some of the students have said, open chaining, right? Separate chaining, right? Linked list. They are the collision resolution techniques. Hashing is not collision resolution. Hashing is to map a key to an index of an array. That's it. If it results into collision, then we have to find out some collision resolution technique. Therefore, I am making a note. Collision may occur in hashing, but hashing is not a collision resolution technique. Resolution part is not there. It is only meant to find out what is the index corresponding to that particular key. Right? It is not bothered whether at that particular index some value is there or not. Its only job is to subject the key to a function to result into an index value. That's it. It's not a collision resolution technique. So they are two separate things. Do not mix it up. So this collision resolution technique, and some of the students were saying separate chaining, or some of them were saying open hashing. The other is open addressing, or it's also alternatively called as close hashing. In that, linear probing, quadratic probing, double hashing, which are the part of your syllabus, all is going to come. All is going to come. Okay, so let's start with the first one, that is separate chaining. Collision resolution, specifically corresponding to separate chaining. Now, the separate chaining is one of the most commonly used collision resolution technique. Separate chaining is one of the most common collision resolution technique. It's not the only one, but it is one of the most common ones. That's what I'm trying to say. Do not get away with an idea that this is the only way we can do collision resolution. There are multiple ways. Right. It is usually implemented by linked list, as some of the students have already guessed it. Absolutely correct. It is usually implemented by using your linked list concept. Okay. In separate chaining, each element of the hash table is a linked list. Are you understanding, students? In separate chaining, each element of the hash table is a linked list. Means you are giving the key to a hash function. That hash function results into an index. At that index, there is a linked list. At that index, there is a separate linked list. Okay. To store an element in a hash table, you must insert it into a specific linked list. So that key value pair, for that, first you have to find the index, go to that index and store your key value pair there. So to store an element in the hash table, you must insert it into a specific linked list. Right? Each is a linked list. So in one of the linked list, your key value will be there. One of the linked students, are you able to understand? Some of the students are trying to use the chat window. Are you trying to talk to me? Is there anything to be clarified? Use the chat window effectively. To handle the collision, this technique creates a linked list, and the linked list will add or append the node at the end. The new key is then inserted in the linked list. In case of collision occurs, the new key is inserted in the linked list. These linked list to the slot appear like in a chain. That is why this technique is called as separate chaining, right? The linked list, there are several linked lists. There is not one linked list you are talking about now. Corresponding to every index. Suppose the division factor is 7. So you have 7 indexes starting from 0 to 6. Corresponding to 0, there is one linked list. Corresponding to 1, there is another linked list. Corresponding to 2, there is a third linked list. So multiple linked lists are there. Multiple linked lists are there, right? So that is what is, and in the linked list, every node is chained one to other. Therefore, multiple linked lists. So separate chaining, right? Each is a chain, and there are lot many chains, lot many linked lists. Therefore, it is separate chaining. Now coming to the time complexity. Coming to the time complexity, Nikhil Reddy had asked me, will it create a problem during searching, right? So that is what I am coming to Nikhil Reddy. I think your doubt will be further clarified. Further clarified. Time complexity for searching, right? In the worst case, all the key might map to the same index. What I am talking about bucket, all the key are mapping to the same index of the hash table. What the worst case? You can't overrule this possibility. All the keys are in such a manner that when your division factor is some x, that key, the percentile x, is resulting into the same index. You cannot rule out that possibility. So that's my worst case. So if we look at the worst case, in such a case, all the keys will be present in a single linked list, isn't it? I have come to the same index, and at every index there is a linked list. But unfortunately, all the keys are, so when subjected to the hash function, are coming to the same index. So I have only one linked list. So when in that one linked list, I have to add the entire data. So sequential searching will have to be performed on the linked list to perform the searching, right? Sequential searching, because unlike your skip list, when you are inserting a node in the linked list, you are not going to sort it. We are just going to append. Since you are going to append, the linked list keys are going to be in a haphazard manner, right? They are not going to be in a sorted manner, but they are going to be in haphazard manner. Since they are going to be in a haphazard manner, you cannot apply the skip list logic on this linked list, right? So what is the alternative? I have to start from the root node number 1 and keep on looking for till the node number last, right? Till the time I go to the node number last. If there are n number of nodes, the loop has to run n number of times in this worst case, right? So this big O notation n, is what is a representative of the worst case of time complexity. So the time taken is directly the time complexity function On is directly depending on the number of nodes. More number of nodes, more time required to search for the key and the corresponding value. Okay, so that's the time complexity for searching. Similarly, time complexity for deleting, right? Time complexity for deleting. You can delete, but before delete, first you have to search it, isn't it? If the node is existing, then only you can delete. If it doesn't exist, then unfortunately you can go up to the last and say that the node does not exist. So in this case also, in the worst case, the key might have to be searched first and then deleted, right? To delete the node, first you have to search. And just now in the previous slide, I said the worst case of the search. In the worst case, the time taken for searching is On. In the worst case, the time taken for searching is On. The time taken for deleting, there is a time complexity for deletion is also On. The time complexity for deletion is also On. Students, are you understanding this? Time complexity. Is there anything to be clarified? Yes, I promise if you are able to understand what I'm trying to say. Okay, the chat window is, yeah, yeah, Durga Prakash, anything? No? Okay, fine. Now, there's something called as load factor. Load factor. I told you that suppose my division factor is 10, means what? I have an array which has got 10 indices starting from 0 to 9. Okay, but if the number of data has gone in such a manner, it has gone so big that I have to find something like a load factor. So the number of elements present in the hash table divided by total size of the hash table, that will give me the load factor, right? And then you have to decide if the load factor goes beyond 0.75. If the load factor goes beyond 0.75, then you may think of increasing the size of the array. Then you may decide to increase the size of an array. How does it help in increasing the size of an array? Obviously, instead of 10 array indices, if I had 20 array indices, so there are the what was earlier in 10 linked list can get distributed in 20 linked lists, right? So the search operation can become faster, right? So that is one way of finding out the load factor. Number of elements present in the hash table divided by total size of the hash table, right? So this is the load factor is defined like this. If the load factor is a constant, then the complexity of insert, search and delete becomes theta 1. Becomes theta 1. So the load factor, if it is constant, to make it constant, sometimes you have to do, you have to increase the size of your array. You have to increase the size of your array. Now let's come to the performance of your chaining. The performance of hashing, the performance of hashing can be evaluated under the assumption that each key is equally likely to be hashed to any slot of the table, right? Any slot of the table. Means what? Let's see it with an example. M, number of slots in the hash table is say M. Yeah, Gayatri. Yes, we are saying why just in worst case, why not in every case? See, Gayatri, what is the worst case I've considered? The worst case is that every key is hashing to the same index. So if there are 10 nodes, and unfortunately each of the 10 nodes are hashing into the same index, say 1. So though I have a possibility of creating 10 linked list, but because each key is getting hashed into only one index, I am creating only one linked list. If I am creating one linked list and if there are 10 elements, I have to run the loop 10 times. In the worst case, unfortunately, the worst case is what? Unfortunately, the element which I am searching happens to be the last element in the linked list. So I have to go n number of times. So 10 number of times. Now you are asking the second part of your question. So why the worst case? Why not every case? If the situation is like this, that multiple indexes have been hashed, means the key has not hashed every time to one index, but has distributed into multiple indices. Since that 10 nodes or the 10 values have got distributed into your multiple linked list, the search operation is definitely less than n. The search operation is definitely less than n, right? So, barring the worst case, the time taken to search, a particular key value pair is lesser. So every case is not a worst case. But whenever we do the time complexity and what big O notation, the big O notation is always going to look for the worst case. Gayatri. Okay, you understood? So it's something like that. The worst case, like why the colleges are not starting. The government has taken the worst case. What the worst case? Maybe this complete semester may get washed out. Doesn't matter. Let the semester get washed out. But let us not subject these students to corona, and in every house there is a tragedy, right? To avoid that, we are ready to take the worst case. That the worst case is what? The corona has started in March, probably it may go up to December, doesn't matter. The lives of every student and the parents and their family are more important. So close the college up to December 2020, right? So if we are preparing ourselves, so there could be alternatives. There could be alternative. What the alternative? We have moved from live classes to online classes, right? Solutions can be found out. Okay, so let m be the number of slots in the hash table and n the number of keys to be inserted in the hash table, right? In the hash table. So the load factor always is, say, alpha n by m, right? So 1 plus alpha, this particular load factor, if this particular load factor for searching, for deletion, and for insertion is constant, if it is constant, the time complexity of search, insert, and delete is O1 if alpha is O1. Now, I have not covered this time complexity by teaching you what is this big O notation, right? So what I have displayed in front of you is little bit difficult to understand. What I'm planning after the end of unit 2, instead of directly moving to unit 3, I'll take a pause, and first explain you what is this big O notation. Then you will appreciate what I'm trying to express in terms of your load factor. So at the present, let's spend this topic, because no matter how many questions you ask and how much of explanation I give, unless I explain you what is this big O notation and how the computation of this big O notation is done, how do you convert your software coding into a mathematical model, right? That is what is your big O notation. So unless I explain how to convert this software, the coding technique or the coding algorithm into its equivalent mathematical model, you will not be able to appreciate when I say this O notation, right? So presently, let us spend it, and I'm assuring you that at the end of the unit 2, I'll give a pause before going to unit 3 and first explain you what is this big O notation and how to compute this big O notation. Okay. So before I go to open hashing, uh, which I'll continue on Friday. I'll continue on Friday. There is a quiz. So give me sometime. Yeah, students, before we actually handle this open hashing, first take the quiz, and then on Friday we'll continue with the open hashing. Okay, thank you. So, yeah. चलो गरम करो ना.
Yeah, bro. Is my audio is clear? Yeah, it's a little bit louder. Okay. Okay, Surya. The last month I given quiz of 10 MCQs and I given my program also, right? Program number 4. Program number 4, right, is called dynamic inside. So there, there are totally 354 students are tried to solve this. They tried this program. Out of 542, 354 are tried. In that one, 198 students have solved this puzzle. You can call it a puzzle or you can call it question. Just projecting the student names. So they got what are the problem statement I gave in? They successfully completed that one. So before that one, there is today also I want to give a small update of the previous program. Latest that is called program number 5. Along with today we had a quiz which covers the hash. The previous class we taught about the hash functioning. We have the 10 MCQs and 10 minutes of time that also is there. And today I want to activate one more program. The program got some point about. Before that, I will explain the program. Right. The best way is I explain the program, then I will start with the previous quiz. Right. Yes. The program I was given today, the statement. You have to write a C program, create a linked list, and perform the following of. So you done already done that insert student details. It's like a student roll number, name, and code. And you also done the previous one is a deletion, right? And the deletion has been a node want to delete the previous one. And here you have to display the student without don't want any alphabetical order arrangement, not be any. Just displaying the then there is a right? In insertion, three things. Yes, you have to it has to have a where you want to insert it, beginning or it end at a particular position. We'll go through that input and output. So it has a display access. Session do you want to perform it for internet? So insert, display, or exit. So if I say insert this one, the insert ask that Way to insert. Insert begin. Insert at end. Insert at particular position. So I'm trying to insert roll number in batch. After that one, again it has to come to here, starting point. Again it has to display that which operation do you want to perform. It want to insert, a display, and exit. Yes, I want to insert. Insert one. So it has to form that one. Insert at beginning. Insert at particular position. So what I will do, I will insert end. Means 20. What is the roll number? The RN is the name of. After that one, again it has to come to the loop, main point. I mean, the same starting point. So it's a loop, right? So which operation do you want to set this one? Setting. The third one I want. It asks where to insert. It's an insert at beginning and or a particular position. I'm asking for insert at particular position. So which position do you want to insert? One, third level, whatever. I'm asking values. Then again it has to come to the same loop. It has to ask this. So it has whether are you going to check that like as whatever. First we inserted this one. Next we inserted as a Arun. First we inserted Ram. Then we inserted the student as Arun. And last we are asking their positioning, right? Which position second node. So in the second node we are inserting. So it is a sequence 10 Arun and bridges. It has to print like this. You're clear guys? I want to give a diagrammatic, right? First you insert one node. I'm inserting from node 1. So it has to, first it has to ask that one. If you want to insert, do you want to display, you want to exit. I want to insert one. Pressing one, you're going to allocate some memory in that one. What are the memory? 10 RAM and CSC department along with some address. Okay, so it's a beginning because that it doesn't have, first of all, when writing the program nothing is there. So in the null position it is the first position. If there is nothing there, it is that no nodes has to be, it has to prompt that one. If there is a no thing is there, if I try to display, it has to print that no nodes are there. If there is nodes are there, so initially we doesn't have a node. First we created one node called n1 and we inserted from these values. These values we inserted. Then afterwards, then again it asks which position you want. You want to insert at beginning, you want to insert at end. So this is the beginning. This so my to that one, insert at end. So this is the end. So again I'm going to create a one more node here. A node, creating a node, right? Node, right? Insert the value. Again it will prompt that one. You want that you want you want exit. I want to insert. Pressing the insert value. So where do you want insert? Beginning. This is the beginning. Now end here. This is beginning. So this is node 1, node 2. Beginning, if I say, it has to print here. It has to insert here. If I say end, it insert here. So I'm asking the position. Like which position do you want insert? Node 2. So node 2, what will happen? Going to create one node. Now this is node 1. Which position? This is position number 1. I want to insert position number 2. So position number 2, I'm going to insert. Instead of here, I will cut this link. I want to insert this into this one. So node 1, node 2, node 3. Say display it 1, 2, 3. I don't want to go for alphabetical order. In the previous one I give. Don't go for alphabetical. Got to print the chain, normal chain. Right? This is today's program. Hey guys. So this is today you have to perform. This will be same thing. Going to end before the class. Class is before class begins. I am going to start 1.5. I'm very happy that one. And 150 students are very happy. So what are the punishment going to give? I don't know about the remaining students. For them, tomorrow, Thursday class, they have the doubt. If they are not understand the program, teachers are going to help to the team. What is here the concept? That concept into the logical code. And if you are that how to fit the logical programmer. Okay, I'm very happy with 150 students. I don't know about the rest of them. Please try and solve this one. And this is going to helpful for your placement also. Okay, guys. And today is this statement. You have to create a linked list of a student details. Insertion. I'm updating it three updation, right? You want insert at beginning or end a particular position. Insert beginning means front. Insert at end means I want the particular position. Which position? सबसे पहली बात आप बीएमसी ऑफिसर हो या कोई भी हो किसी के भी घर में इलीगली आप घुस नहीं सकते हो बाय इंटिमिडेशन एंड बाय थ्रेट तो बेसिक बुनियाद जो है पूरे केस की वो यही है और वही चीज जज के सामने रखी गई थी आज और ऑनरेबल जजेस को समझ में भी आ गई होगा कि क्या है मेन बेस जो है हमारा ये रेट में भी कवर्ड है और इसी वजह से मैं क्रिमिनल केस भी फाइल करने वाला हूं उनके ऊपर और सेक्शन 166 का प्रोसीडिंग भी फाइल करने वाला हूं कोर्ट में क्या करना है अभी केस खत्म नहीं हुआ है अभी कल 3 बजे फिर से मैं करें अब उनको एफिडेविट उनको एफिडेविट फाइल करना है डॉट इन द प्रोग्रामिंग डेकोरेशन ब्रांड था उसके बाद देखिए म्युनिसिपल ने क्या किया है अभी वो मैंने सुना केस है मैं उसमें नहीं जाना चाहूंगा मगर ये इतना मतलब जिस हद तक वो जा सकते हो मैंने आज देखा मेरे मोर देन 20 इयर्स ऑफ एक्सपीरियंस में मैं कभी नहीं देखा पीएमसी को करते हुए कि सुबह 10-19 को नोटिस का रिप्लाई भेजते और उसके पहले वो आदमी मौजूद हो जाता तोड़ने के लिए Is it clear, guys? Yeah. Your background sound I was removed. Actually, the sir was not disabled, Umesh sir. So just now I called him and he was disabled and sound. Right? And I'm activating the two-way quiz also. It is an hardly questions. It's a way. It's what I can call it and just a definition. Yeah, sir. No problem, sir. No. Before that one, meanwhile, what I will do, I will on the quiz, and I want to discuss the previous quiz solution also. So it's taking the time for load. Yeah, it's loaded successfully, and I want to activate the quiz as well as the program. Yeah, and the program is you have to do an updation of insertion. In the previous program, as is, but insertion should be done at the beginning, end, and middle one. And display function, I don't want an alphabetical order. I want an whatever that position, what is the chain, I want to print the chain. I don't want to the jumbling chain, right? Don't want to any alphabetical sequence order. Just I want an order called chain order. What is the chain order? It has to print it. Yeah. Yeah. I'm starting a quiz. Yeah. Quiz is started, and program also I'm going to start.